Hi everyone, the topic of this presentation is bringing consequence modeling to the cloud, unlocking real-time insights with Phast APIs. My name is James Pickles. I'm a principal product engineer with DNV. My background is in physics, and for the past 20 years or so I've worked in the process safety industry. For 13 of those years I was on the consulting side, primarily involved in consequence and risk modeling of loss of containment scenarios on hazardous facilities. And then in 2018, I moved across to the software side of DNV, initially as product owner of DNV's Phast and Safety software, then as product manager, and then around 2 years ago, I moved across into a software developer role for the same products, but I've been focused on the API side of things, so making our models available as APIs, which I'll get into shortly. I'd also like to mention the co-authors of the paper. So firstly, Dr. Nick Kavanagh, who is a Vice President and Head of the Plant Product Center, which covers the consequence and risk modeling software that I've mentioned. And also Dr. Marek Vasilevsky, who is our Chief Architect for the same products. The background to the paper is that technological advancements are enabling deeper integration of consequence and risk modeling into process safety workflows. Now, when I talk about consequence and risk modeling, I am referring to the discharge, dispersion, fire and explosion modeling following a loss of containment of flammable and/or toxic materials. We believe that readily available consequence and risk data will improve process safety, whether that's making decision-making processes more efficient or by providing better insights. And a good example to give is with emergency response. Now, currently, it wouldn't be practical for an emergency responder in the event of a loss of containment on a facility to open up some consequence modeling desktop software such as Phast to run some scenarios and understand what sort of potential scenario they might be dealing with. That wouldn't necessarily be practical. However, it would be possible for a web application to be created for that specific situation. And the web application could retrieve live process data and live weather data to then run a consequence model that's hosted in the cloud, and for the results of that model to be displayed back in the web application to the emergency responder. So that is something that is possible with technologies that are available today. Further, the limitations of traditional desktop-based modeling tools are becoming more apparent. So what I mean by that is the current interface is not being tailored to solve any one problem, but actually trying to solve 1,000 problems. Consequence and risk insights are most powerful when they can be accessed at the point of need, during operations, maintenance activities, and emergency response, for example. And the current consequence modeling interfaces do not lend themselves well to this. The digital transformation taking place is ensuring that we can meet the demand for more agile and bespoke solutions for decision-making processes. So to summarize what we mean here, we are referring to the transition from having a single, likely highly complex interface to having multiple interfaces or bespoke solutions at scale. Now, I'd like to spend a few moments giving a brief history of the Phast consequence modeling software. Now, I'm referring to Phast, but actually DNV has other consequence and risk modeling software such as Safety, KFX and XIM, the latter two being our CFD based tools. But these 4 items of software have all been developed over a similar time period, as has other consequence modeling software outside of DNV. Now, in the late 1970s, there were some recommendations following a public inquiry into the safety of installations operating in the Netherlands. Following those recommendations, in 1981, the Dutch Ministry of Health and Environment commissioned Technica, which later became part of DNV, to develop a software system for risk assessment of chemical plants. In 1982, that was given the name SOFETI, which stands for Software for the Assessment of Flammable, Explosive and Toxic Impact. And in 1983, that software was delivered to the Dutch Ministry of Housing, Physical Planning and Environment. In the 1990s, there was a growing regulatory need for consequence modelling, particularly in the US. And as such, the consequence models were taken from SOFETI and built into a new software called the Process Hazard Analysis Software Toolkit, otherwise known as Phast. Now, in recent years, DNV has been building the infrastructure to enable the models, the intellectual property, to be called from the cloud and to be used in flexible and custom-built ways using cloud-based APIs. I've spoken previously about the limitations of existing approaches, so let's take a look at that in more detail. Now, position yourself for a moment as a software vendor, a software provider. You need to be able to make profitable software. Now, imagine that the size of your market is such that you have 1,000 users of your software. Now, in order for your software to be profitable, you make a single user interface, and every user of your software uses that single interface. So that's easy to scale. Unfortunately, the user must then adapt themselves to that user interface. That user interface is not tailored for their specific needs. So that is less good for the user. Now, let's take the opposite approach, and let's suppose that for every one of these customers, we create a bespoke, unique, tailored user interface for their needs. That's great for the user because now the interface is adapting to the user. So that's great for the user. However, that's very difficult to scale and that's difficult to make profitable. So this is the challenge that we face. Now, we can meet this challenge through the technological advancements that have been made in recent years. So there have been rapid advances in computing infrastructure and software architecture that have meant that models can be delivered and consumed in different ways. And the API is central to this. So what is an API? An API, an application programming interface, is a structured way for software systems to communicate with one another. Now, it's worth conceptualizing this and thinking about, imagine yourselves going to a restaurant and you sit down at your table and you're provided with a menu and you choose off that menu what it is that you want to have for your meal. The waiter or waitress comes and takes your order, your request. So your request then goes to the kitchen, and the kitchen knows how to respond to your request because they know that you've picked something from the menu. So they then make the meal, they do some work, and the meal is then delivered back to you, to your table as a response. Now, when we talk about APIs, this is what's happening. So when we talk about consequence models being available in the cloud, so that's the kitchen effectively, then we can send a request into that model via the API. So within that request, if we're running a model that's available in the cloud, we might want to run a vessel leak model, for example. So in the request, we need to specify the pressure, the temperature, the hole size, the material in the vessel, for example. So the request has to go in a certain format and there's certain information that is required. Then the model in the cloud performs its work. That's the kitchen, cooking the meal, making the meal. And then the response from that vessel leak model goes back to you as the user. It goes back in a structured format. It follows certain rules. So the advantage here is consistency. The rules for sending requests and receiving responses are clearly defined. And this means that APIs can be used by different systems, from custom built web applications to automated scripts and dashboards. In effect, this means that APIs can turn the underlying consequence models into services that can be plugged into a much wider range of digital workflows. Now, in terms of models being hosted in the cloud and accessed via an API, there's various platforms that are available for this. So there's Microsoft Azure, which is what we use at DNV, but also Amazon Web Services and Google Firebase. These platforms provide us with enterprise-grade security, performance and monitoring, and it allows the rapid scaling of computing resources to deal with the demand on the API. And this is where the analogy with the restaurant and the kitchen falls down. Now, imagine within the restaurant, there's 1,000 customers queuing at the door or sat down at tables, all ordering their meals within a short time period. The kitchen would struggle to deal with all of those requests, and the requests would be queuing up, and people would have to wait a long time for the response for the meals. With these platforms such as Microsoft Azure, the computing resources can be rapidly scaled up. So let's suppose that there's 1,000 users of the API all sending in requests within a short time period. Microsoft Azure and others will automatically scale up the computing resources to deal with that demand, so that effectively it doesn't matter whether there's 1 request, 10 requests or 100 requests being sent in within that short time period. We don't have requests queuing up at the door. They can all be progressed at the same rate. This is one of the significant advantages of the technological advancements that we've seen in recent years. We're no longer limited to the computing resources of the user's laptop. Now, DNV's consequence models, the Phast models, are hosted in the cloud using Microsoft Azure and accessible via an API. And we have created a number of what we call client libraries to make it easy to be able to use these models. So for example, we have a Microsoft Excel add-in where you can write functions for running models and receiving results back to Excel. We also have a Python library called PyPWS. Again, this makes it easy for Python developers to write code to be able to run these models and interrogate results. And we also have a .NET library for .NET developers and a TypeScript library for TypeScript or web developers. Now, with the rise of AI and the availability of large language models such as ChatGPT has really changed our relationship with computers, moving away from those traditional point and click drop downs data entry type interfaces to a conversational based interface or a conversational based experience. So we try to conceptualize this in the image on the right hand side, so we can gather data from facilities or sites that's available within a digital twin, and we can converse with agents that perform work on our behalf. Those agents can gather data from digital twins and send that data into the Phast models via the API, receiving the appropriate response back. And this means that the experience is then really tailored to the individual through this conversational-based way of working. Now, in this way, this data, the digital twins or the digital platforms are then at the center of all of the work that is carried out on a facility. So the digital twins or the digital platforms can harvest data from a site, whether that's sensor data, environmental data, production data, and so on. And this then becomes the hub or the single source of truth, if you like, for all of these different types of workflows that are carried out on a facility, be it RAM analysis, risk analysis, RBI, and so on. Now, I'd like to give some examples. Some of these are conceptual, some of them are real, of how this improved integration of services and data and models provides benefits for process safety. So cloud-based consequence models really opens up new possibilities for integration with other data sources and digital platforms. So a really good example is a weather API, which provides real-time and forecasted weather. So we could build a web application or a platform or a service that is able to gather weather information from a third-party weather API, and there's lots of them out there. If you just do a Google search for weather API, you'll get lots of responses back. So there's lots of those available. Some of them are free to use, some of them you have to pay, or certainly above a certain usage. So we could build this custom-built interface that is tailored for a very specific workflow, which gathers data from those weather APIs and also interacts with the Phast models in the cloud via the API to solve a particular problem. Example use cases, I mean, I mentioned emergency response much earlier on. That's the classic use case of weather APIs. But also when planning activities, so we might want to discuss potential hazards when planning activities, so we could use forecasted weather data to give us much better predictions of the likely consequence effects or potential consequence effects. Another quite similar example is with the use of live and or historical process data from digital twins and using that as input into the consequence models. This offers real efficiency improvements, no longer having to do manual data entry, and also can be used for planning activities, emergency response, of course, and much more. Next, I'd like to show a web application that was developed by a third party, which shows the concept of data from different services and sensors, location-based services and gas detector sensor data, in this case, being used together with the Phast API in the event of a leak scenario, being used to predict the dispersion zone, and thereafter that could inform certain emergency response decisions being taken. Now, hopefully you can see from that they designed quite a simple user interface that was tailored for a specific problem. And I'd just like to highlight the third bullet point on your screens now, which is intuitive user-focused design eliminates need for training. So by the third party building a specific user interface, a simple user interface in this case, designed to solve a particular problem, then that eliminates the need for training in, let's say, a more complex traditional desktop user interface. Next, I would like to show how the APIs enable rapid sensitivity analysis. Now you can see an example of that on the screen. What's actually happening here is that as the input data is being changed, the API is called, which reruns the models, and then the results come back to this Excel workbook. This is actually showing thermal radiation or heat on a tank that is neighbouring a tank that's on fire. And then the user is simply changing the assumptions such as the tank diameter, tank height and distance between the tanks. And then we can see that changing those inputs invokes the models, and then after the model is rerun, the results come back to Microsoft Excel. Now, one of our customers, Abbott Risk Consulting, have been using the APIs, and they say this in terms of sensitivity analysis. This new way of accessing consequence models means spending less time wrestling with the software, more time being safety engineers, as it is now much faster to play with risk models to understand the level of uncertainty in calculated risk results and the impact that design changes can make on the risk profile of a facility. It frees up more time to use this information to make thoughtful and robust safety recommendations that improve the safety of our clients' facilities. The last example I'd like to show is from a company called Eastman Chemical Company. They have used the APIs to transform established workflows. They conduct process hazard analysis on a regular basis across its sites, requiring estimates of the likelihood and severity of potential hazardous events. They faced challenges in the traditional workflows, which was having limited availability of experts, lack of control over inputs, and inconsistency in the modelling approaches. So their solution was that they developed their own web application for their PHA process, integrating the APIs and exposing only the necessary inputs for their process. This really exemplifies the shift from software vendors providing a one-size-fits-all interface to organizations or third parties building tailored solutions that meet their specific needs. So to conclude, organizations are already realizing the benefits of this new approach, from accelerating sensitivity analysis to standardizing hazard assessments across global facilities. These use cases demonstrate that APIs do not just replicate what desktop software could do, they unlock entirely new ways of working with greater speed, flexibility, and accessibility. Further opportunities will emerge as consequence modeling APIs are combined with other technologies, such as IoT platforms and large language models. In the near future, conversational agents will be able to call APIs directly based on natural language prompts, making consequence insights available to a wide range of stakeholders in more intuitive ways. Thank you for listening.